Okay, so the next concept to discuss is the concept of reference dependence. And this is very well illustrated with this famous optical illusion. Some of you guys may have seen this illusion before. Okay, so I want you guys to answer a simple question. Okay, which is darker? This cell right here, okay, this box right here, or this square down here? A or B? Which one is darker? And I think if you're like most people, you would conclude that A is darker. But of course, they are actually exactly the same tone. Yeah. And so, okay, so obviously what's going on here? Well, the reason why this one seems darker is because it appears darker in the context of what's being presented to you. This is being shown as in the shadow of this green cylinder thing, right? And so that example sort of embodies this concept of reference dependence. Reference dependence is the idea that every choice is relative to something else. And if we change that reference point, okay, if we change that reference point against which people are comparing, that can often change people's decisions. Okay, so once again, we'll look at a few different examples of this phenomenon. Okay, example number one is and this I mean the Olympics are like canceled, right? But well, we can think about a past Olympics. Okay, if you watched any of the past Olympic games, you may have noticed that during the medal ceremony, the athletes who are winning a bronze medal usually appear to be happier than those receiving the silver medal. Here's some pictures of athletes receiving the silver medal to sort of prove this point. Okay. And this effect has actually been confirmed. There have actually been studies where people, are asked to look at these athletes and evaluate their facial expressions, and consistently you see that the athletes receiving the bronze are happier. And well, the reason is kind of what you would expect, right? So, those who won the silver medal often had expectations to take the gold, and so they're disappointed. Whereas those who won the bronze, often they're underdogs who are happy to have gotten any medal at all. So, this effect, which I'm sure, all of you guys are sort of, familiar with in your own lives, this effect is very fundamental. And it exists down to the level of individual neurons in the brain. And in particular, it appears that that dopamine signaling in the brain is very contingent on the difference between outcomes and expectations. Okay, so basically, okay, well, it's I guess we should do a quick primer on this. So you guys probably know. So in your brain, right, there are neurons, okay, and these neurons, they're all connected to each other in this giant web. And the place where two neurons touch, that's known as the synapse, okay. And so for you to be able to do things in your brain, these neurons have to fire, and when they fire, okay, that message, that action potential, as it's called, needs to be able to cross the synapse. And located in the synapse between any two neurons are a bunch of these chemicals called neurotransmitters. You may have heard of them. Dopamine, serotonin is another example. Glutamate is an example. Okay, so and these neurotransmitters, they modulate the activity in the brain, and one of the most important neurotransmitters is this neurotransmitter called dopamine. And dopamine, um, especially in the frontal cortex of the brain, plays a very important role in how people make decisions. And so these dopamine neurons, okay, that are in your brain, what's been found in both animals and people is that they respond to reward, okay? But they don't respond to the magnitude of the reward. What they respond to is the difference between the reward that you got and the reward that you expected. Okay, and so I'm actually going to save the rest of this story for the listening. Okay, the listening is going to feature an example that has to do with these dopamine neurons and the way in which that they respond to reward. and it's going to talk about a woman with Parkinson's disease. Okay, so she gets Parkinson's disease. She gets treated with this medicine that ups the dopamine signaling in her brain, and then she becomes a compulsive gambler. Okay, it's a fascinating story. So I'll refer to the homework. Okay, for that. But okay, so let me give you guys another example. Okay, so we have this, this effect that's, deeply built into us down to the neurological level. There's another example of reference dependence is something called the endowment effect. And the endowment effect describes the tendency of people to overvalue what they already have. Okay. So, for example, right? Suppose that when you attended the CNU career fair, as many of you did, you acquired a free CNU mug. Okay, it's just a mug with the CNU logo on it. Right. Now, say you were given the chance to sell that mug. How much would you be willing to sell it for? Well, most people in that situation, they're like, well, I mean, I did get this mug at college, I can it's sort of a souvenir, later on, after I graduate, it can remind me of the good times I had in college, so I don't want to part with it too easily. So maybe it's worth $10 or something like that. But imagine you were presented with the opportunity to buy that same mug. Well, in that case, it's very unlikely you'd be willing to pay $10. You maybe only be willing to spend a couple of bucks. Okay, so already owning the mug shifts your reference point. Okay, and so it changes the price that you're willing to pay for the mug. It changes what you're willing to accept. Um, a very similar thing applies to really any kind of random assignment. Okay, so for example, there was a study at Duke University that examined the school's lottery system for tickets to basketball games. Now, I'm sure you guys know Duke has a very strong basketball team, right? So if you're a student who happens to go to Duke, the basketball games are very popular. And so there's so much demand that you got to sign up for a lottery. And so the students sign up for this lottery, and if they win, then they're given the opportunity to purchase the ticket, and usually it costs around $100. Okay. And once again, you sort of, based on whether or not you received, whether or not you won this lottery based on whether or not you won this lottery, you see a very significant difference in people's willingness to pay and how they value these tickets. Okay. So, for example, if you're looking at the championship game, those who win the lottery, they really want to go to the game, and they usually sort of, if you talk to them, they'll sort of frame it in the sense of, wow, this is like a once in a lifetime opportunity to see, the NCAA championships while I'm at Duke, and they value the tickets a lot. They often, they're only willing to sell them for, let's say, $1,000 or more. Okay. However, students who didn't win the lottery, they tend to sort of view the situation quite differently. Okay. They will usually say something like, well, like a whole bunch of hype, but the tickets are very expensive. It's going to be very crowded. I'm more interested in the parties after the game anyways. They're going to sort of tell a different story. And if you see how much they're willing to pay, often they're not willing to pay, $1,000. They might only be willing to pay $100 in order to acquire that same ticket. Okay, so now this effect, okay, this endowment effect, is actually how most behavioral economists explain risk aversion. Okay, so consider the coin flip example that I gave you in an earlier lecture, right? So in an earlier lecture, when we were talking about expected value, I said, let's say that you can choose between a 50-50 chance of getting 0 or 100 versus getting $50 for sure. And we tried to explain this choice then, okay? We tried to explain why so many people would prefer $50 for sure, despite that this game also has an expected value of 50. Okay, but The explanation that I gave then had to do with diminishing marginal utility. Okay, with this idea that the even though in expected value they're the same, the expected utility of the $50 is greater. And frankly, a lot of behavioral economists were not impressed with this explanation. And they instead would offer quite a different explanation for why people prefer the short $50. Okay. And I actually kind of agree with them. I think that this way of looking at it is more accurate. Okay. And so in this view of looking at things, basically what happens is people, they don't really see the choice in the same way as you might expect. So if the option exists to take $50 as a sure thing, right? So imagine you choose the lottery, okay, and you lose, okay. Are you really going to view that as basically, well, then I just broke even, no big deal. I'm no worse off than I was before, right? I mean, that's true. You're no worse off. But you see, you had the opportunity to get $50 for sure, right? So if you take that gamble and lose, a lot of people wouldn't view that as breaking even. A lot of people would view that as a loss of $50. Okay. So which is better? Having a 50% chance of winning $50 or having a 50% chance of losing $50 versus getting $50 for sure? I think in that situation, far more people would accept the $50 for sure. Okay. So I hope that makes sense. Okay, so that's yet another example of this endowment effect. When you're given the opportunity to have $50 for sure, it's like you're sort of thinking, okay, I already got that $50 in hand, and then you're viewing the other choice as sort of um, relative to that. Yeah. Okay. We'll go over two more examples. I know it's a lot of different examples, but this is sort of a very widespread phenomenon. Okay. Um, okay. So imagine that you're buying a small refrigerator for your room. Okay. And these small refrigerators, if you go look up how much they are online, they like cost more than you think they do. Okay. So for example, have a look at this fridge. Okay. Say that this holds 24 cans of your favorite beverage, and this costs 75. Okay. And this slightly larger refrigerator, it holds, 150% more, but it also costs 150% more. It costs $125. Okay. Which one are you going to pick? I think in this situation, okay, a lot of people would probably pick option A. Okay. I mean, how many cans of soda or beer do you really need to store? Let's just go with option A. It's $50 cheap. Okay. Now imagine, however, that instead of being presented with those two options, you were initially presented with all three of these options. Okay, and so I've added a third option here, option C. So this option holds 30 cans and costs $160. Okay, well, if people behave completely rationally, okay, um, if you chose item A in this case, you would also choose item A in this case. You wouldn't be tempted to switch to item B just because I added a third choice, right? Why is that? Because this choice, option C, seems clearly worse than both of the first alternatives, okay? But when you were presented with this, I bet that's not what you thought. And that's not what I think either when I'm presented with this choice. When I'm presented with this choice, I see option C and I'm sort of like, oh, man, this thing kind of sucks. But, wow, look at option B. That holds more cans and costs less. It kind of makes option B look like a better value. Okay? So this is known as the decoy effect. So we introduce this irrelevant third choice, the decoy, and all of a sudden we can convince people to buy the more expensive good. Okay? Firms, they know this, and they actually, advertisers, they use this strategy all the time, right? So how many times when you go to a movie, say you go to a movie and you look at the options for buying drinks, right? And you see the small drink listed there for $3 and the large drink listed for $3.50. Well, I mean, come on, the small drink costs $3. You can get the larger one for $3.50. It makes the large drink look like a much better deal, right? Or you can have the opposite situation. Let's say that, you go to a kind of like a fancy restaurant and you you see some bottles of wine there. And some of these bottles are insanely expensive, right? A 300 bottle dollar of wine. And, you know, by putting that on the menu, it's not just that they're hoping to sell you the really expensive wine, but you might look at that and decide that, okay, yeah, okay, that's sort of crazy, but maybe I'll have this 50 or 75 dollar bottle of wine when you otherwise maybe would have ordered something significantly cheaper. Okay. Okay. So again, this decoy effect. Okay, something good to be aware of, for when you're shopping. Okay. Final example of reference dependence. This is known as anchoring. Okay. Um, it's sort of a similar effect. Okay. So consider the following two questions. Okay. Think about the Milky Way galaxy. Right. You got a picture of it. Actually, technically, this is not the Milky Way. We're inside the Milky Way, so we could never get a picture like this. This is the Andromeda galaxy. But just picture the Andromeda or the Milky Way galaxy, whatever, just some galaxy. Okay. As you guys know, galaxies are comprised of like a large number of stars. Right. So, question: does the Milky Way galaxy contain more or less than 100,000 stars? Question number two: how many stars are in the Milky Way galaxy? Okay, so think about those two questions. Okay, and think about what your answer is. Just come up or write down an answer to those questions. Okay, you ready? Okay, so here's the thing. After being presented with the first question, when people consider the second question, they end up being guided or biased by the first question. Okay, so most people will basically guess an answer that's close to 100,000. Okay, so for example, like let's say you answer more than 100,000 for the first question. You figure, okay, I mean, Milky Way galaxy, it probably contains more than 100,000 stars, right? I mean, you wouldn't be asking me this question unless I had a lot of stars, right? Okay, and then in terms of how much does it actually have? Well, maybe it's five times that amount. Maybe it's 500,000. Okay, or maybe it's even a million stars. Okay, and so what you find is that when people have no idea what the answer actually is, they'll take any piece of available information that they can and sort of go on the basis of that. Okay, and this is called anchoring. This $10,000 value that I just gave you, that's called an anchor point. Okay, and all of a sudden you're sort of evaluating your choice subject to that anchor point. Now, in reality, the Milky Way galaxy contains several hundred billion stars. Okay, it's a million times larger than this anchoring value of 100,000. Even if you guess 500,000, that would still be way, way, way too small of a number. Okay. All right. So, so good. I hope that makes sense. Okay. Again, I think we're, from our daily lives, we're all familiar with this idea of reference dependence. Behavioral economics, it sort of just kind of formalizes that and kind of shows it to you in kind of a convincing way.